Asset deployment is arguably the most critical phase of the IT asset lifecycle from a cybersecurity perspective because it's where theoretical security requirements transform into actual security controls. This is the phase where assets transition from procurement to production, and the decisions made during deployment will impact security for the entire operational life of the asset. Poor deployment practices can create vulnerabilities that persist for years if not found and remediated, while proper deployment establishes a strong security foundation. The deployment phase has evolved significantly over the past decade due to changes in technology and security threats. Traditional deployment processes were often manual, time-consuming, and inconsistent, leading to configuration errors and security gaps. Modern deployment practices emphasize automation, standardization, and security integration, but they also introduce new complexities around cloud environments, containerization, and infrastructure as code. Understanding proper asset deployment is essential for cybersecurity professionals because this phase presents both the greatest opportunity to establish strong security and the highest risk of introducing vulnerabilities. Many security incidents can be traced back to deployment issues like default credentials, misconfigured access controls, or missing security tools. The deployment phase is also where assets are first integrated into the production environment, making it critical for establishing proper monitoring and management capabilities. The pre-deployment preparation stage sets the foundation for secure asset deployment. This involves creating detailed deployment plans that include security requirements, configuration specifications, and integration procedures. Security teams should be involved in developing these plans to ensure that security considerations are properly addressed. The preparation stage also includes preparing deployment environments, testing deployment procedures, and ensuring all necessary tools and credentials are available. Configuration management during pre-deployment is particularly important because it establishes the security baselines that will be applied to new assets. These baselines should be developed based on security frameworks like the Center for Internet Security Benchmarks, vendor security guides, and organizational security policies. Configuration baselines should also address operating system hardening, application security settings, network configurations, and integration with security tools. Risk assessment during pre-deployment helps identify potential security issues before they impact production systems. This includes evaluating the security implications of new assets, assessing integration risks with existing systems, and identifying dependencies that might affect security. Pre-deployment risk assessments should also consider the impact of deployment activities on existing security controls and monitoring systems. The actual deployment process involves several critical security activities that must be executed properly to ensure secure asset integration. The first step is typically installing and configuring the base operating system or platform according to established security baselines. This includes disabling unnecessary services, configuring secure authentication methods, applying security patches, and establishing proper logging and monitoring. Network integration during deployment requires careful attention to security controls. New assets must be placed in appropriate network segments, configured with proper firewall rules, and integrated with network monitoring systems. Network access controls should be configured to follow the principle of least privilege, ensuring that assets can only access the resources they actually need. DNS configuration, certificate installation, and secure communication setup are also critical network integration activities. Security tool integration is a crucial deployment activity that's often overlooked or rushed. New assets need to be enrolled in antivirus systems, vulnerability scanners, patch management platforms, systems and security monitoring tools. This integration should be tested to ensure that security tools are functioning properly and that the new asset is receiving appropriate security coverage. Failure to properly integrate security tools during deployment can create blind spots that persist throughout the asset's operational life. Access control configuration during deployment establishes who can access the new asset and what they can do with it. This includes creating appropriate user accounts, configuring authentication methods, establishing authorization policies, and integrating with identity management systems. Default accounts should be disabled or secured, and administrative access should be limited to authorized personnel. Role-based access controls should be configured according to organizational policies and the principle of least privilege. Data protection measures must be implemented during deployment to ensure that sensitive information is properly secured from the moment the asset becomes operational. This includes configuring encryption for data at rest and in transit, establishing secure backup procedures, and implementing data loss prevention controls. Database assets require additional security measures, including access controls, audit logging, and encryption key management. Compliance verification during deployment ensures new assets meet all applicable regulatory and organizational requirements. That's the goal. This includes verifying that security configurations meet compliance standards, that audit logging is properly configured, and that data handling procedures comply with privacy regulations. Compliance verification should be documented to support future audits and assessments. Testing and validation activities during deployment verify that security controls are functioning as intended and that the asset is ready for production use. This includes vulnerability scanning to identify any security issues, penetration testing for critical assets, and functional testing to ensure that security controls don't interfere with business operations. Security testing should be performed in a controlled environment that mirrors production conditions as closely as possible. Documentation during deployment is essential for maintaining security throughout the asset's lifecycle. Deployment documentation should include configuration details, security settings, integration procedures, and any deviations from standard baselines. This documentation supports ongoing security management, incident response, and compliance activities. Asset records should be updated to reflect the current deployment status and configuration. Change management integration ensures that deployment activities are properly coordinated with other IT operations and that appropriate approvals are obtained. Deployment changes should go through established change control processes that include security impact assessments and stakeholder approvals. Emergency deployment procedures should also be established for situations that require rapid asset deployment while maintaining security standards. Post-deployment verification activities confirm the deployment was successful and the asset is operating securely in the production environment. This includes monitoring system performance, reviewing security logs, and conducting initial security assessments. Post-deployment verification should also include confirming that backup procedures are working, that monitoring systems are receiving data, and that access controls are functioning properly. Automated deployment practices have become increasingly important for maintaining consistency and security across large environments. Infrastructure as code approaches allow deployment configuration to be version controlled, tested, and deployed consistently. Configuration management tools can enforce security baselines automatically and detect configuration drift. However, automation requires careful design and testing to ensure that automated processes maintain security standards. Cloud asset deployment presents unique challenges and opportunities for security. Cloud platforms provide built-in security tools and services that can be leveraged during deployment, but they also require understanding of cloud-specific security models and shared responsibility frameworks. Cloud deployment automation can improve consistency and security, but it requires proper configuration of cloud security services and integration with organizational security tools. Container deployment introduces additional complexity that requires understanding what containers actually are and how they differ from traditional deployment models. Containers are lightweight, portable packages that include an application and all its dependencies, allowing applications to run consistently across different environments. Think of containers as standardized shipping containers for software. They package everything needed to run an application into a single unit that can be deployed anywhere. It's one example. Popular container technologies include Docker, which is the most widely used container platform for creating and running individual containers. Kubernetes serves as a container orchestration platform that manages and scales multiple containers across clusters of servers. Other important container technologies include Containered as a container runtime, Podman as an alternative to Docker, and Amazon ECS or Google Cloud Run as cloud-managed container services. Each of these technologies introduces specific security considerations during deployment. Container security must be addressed at multiple layers, including the container image, container runtime, and orchestration platform. Container images are the templates used to create containers, and they can contain vulnerabilities in the base operating system, application code, or dependencies. Container security scanning should be integrated into deployment pipelines to identify vulnerabilities before containers reach production. The container runtime, such as Docker Engine or Containered, requires proper configuration to prevent privilege escalation and resource abuse. Orchestration platforms like Kubernetes need secure configuration of network policies, role-based access controls, and secret management. Container deployment also requires proper network segmentation and access controls to prevent lateral movement between containers, since containers often share underlying infrastructure and network resources. Mobile device deployment requires consideration of mobile-specific security controls, including mobile device management enrollment, application installation restrictions, and data protection policies. Mobile devices often operate outside traditional network boundaries, making endpoint security and secure communication particularly important during deployment. Common deployment security failures include using default credentials, deploying with overly permissive access controls, failing to integrate with security monitoring tools, and skipping security testing. These failures often result from time pressure, lack of security expertise in deployment teams, or inadequate security requirements. Establishing standardized deployment procedures and security checklists can help prevent these common failures. If you want to develop expertise in secure asset deployment, there are several valuable resources to explore further. The NIST Cybersecurity Framework provides guidance on secure deployment practices as part of its implementation guidance. The Center for Internet Security publishes security configuration benchmarks for common platforms and applications. Cloud providers like AWS, Microsoft Azure, and Google Cloud offer security deployment guides and automation tools. DevSecOps resources from organizations like OWASP provide guidance on integrating security into automated deployment pipelines. Professional certifications like CISSP, CCSP, and various cloud security certifications cover secure deployment practices as part of their curriculum and exams.